Hello everyone, I'm Kelly C. Tagapulot.
And I am Chanel Angie. As you can see on the screen, our topic for today is about flow sensors, also called as flow meters.
A flow sensor is an electrical device that determines or controls the flow rate of liquids and gases within pipes and tubes. Flow sensors, more often known as a flow meter, although they can be connected to computers and digital interfaces, flow sensors are often attached to gauges in order to show their measurements. They are often used in septic systems, medical equipment, HVAC or heating, ventilation, and air conditioning systems, and chemical manufacturing facilities. Leaks, obstructions, pipe bursts, and changes in liquid concentration brought on by contamination or pollution can all be found with flow sensors.
So another definition about flow sensors is a flow meter. Our flow sensor is a device that measures linear, nonlinear, mass, or volumetric flow rates to indicate the amount of liquid, gas, or vapor moving through a pipe or conduit.
According to Ed Edwards, the director of technical content at Thomas, Thomas is a company that powers the growth of North America and number one industrial sourcing platform and marketing powerhouse. Ed holds a BS in Physics and Electrical Engineering from the State University of New York at Stony Brook. According to him, there are three categories of flow sensors. One of that is positive displacement flow sensors. So these sensors are different among flow sensors in that they directly measure the amount of liquid flowing through the device. Positive displacement flow sensors trap a known volume of liquid and move it through the sensor using rotating parts. The rotating parts effectively pass this known amount of liquid through in sequence before allowing more liquid to enter the device. So this is the illustration on how positive displacement works. There are examples of meters using the positive displacement concept of measurement. One of that is the oval gear meter. The differential pressure of the liquid causes the meshing gears to rotate, trapping a pocket of fluid between the gear and the outer housing and expelling the pocket of fluid into the downstream flow. It is primarily designed for use with high viscosity liquids and is used in applications such as oil, syrup, and fuel flow measurement. Just like in this animation, the fluid flows through the oval gears, that's why mo-rotate siya and i-trap niya ang right or specific amount of fluid before niya i-release. Bisan unsa kapaspas ang pag-rotate tungod sa kapaspasad ang flow sa water, same ra gyapon nag-liquid iyang ma-release or distribute. Next is the nutating disc meters. They work by attaching discs to a central ball. When liquid enters the chamber, the disc wobbles or nutates, and the displacement is transferred to a register. As the disc rotates, specific amount of water ang matrap above and below the disc depende sa design sa nutating disc flow meters. And if paspas ang flow sa water, then paspas pod kaayo pag-wobble anang disc pero same amount of liquid japon iyang ma-distribute or release. The fluid enters a precision machined chamber containing a nutating or wobbly disc. The position of the disc divides the chamber into compartments containing precise volumes. Fluid pressure drives the disc to wobble, and a roller cam causes the nutating disc to move a complete cycle. Another example of positive displacement flow meter is helical gear meters, a device that continuously captures a flowing process fluid using two radially inclined helical gears. The flow rotates to helical gear in the plane of the pipe. An optical or magnetic sensor is used to encode a pulse train proportional to the rotational speed of the helical gear. Helical gear meters can measure the flow of highly viscous fluids from 3 to 300,000 cp or centipoise, making them ideal for extremely thick fluids such as glues and very viscous polymers. Maong gitawag siya na helical gear kay ang shape sa gear or iyang rotor kay helix, which is a spiral-shaped structure. Pag mo-flow ang water or ang liquid, Mosulod siya sa compartment sa rotor maong mo-rotate siya and naa say specific amount of fluid iyang ma-distribute. Advantages of positive displacement flow meter. Number 1 is precision components with minimal clearances. Next is provide mechanical or electronic interface. Disadvantages of positive displacement flow meter. Susceptible to corrosion by water-based fluids. Clean fluid is required, and some meters can actually stop the flow if a larger particle becomes trapped in the wrong place.
So mass flow sensors, sometimes called mass airflow sensors. So it is commonly found in automotive applications where it is used to measure the mass air entering the intake system of internal combustion engines. So the output of the sensor is sent to the electronic engine control system. So where it is used as input to determine the amount of fuel that needs to be added to engine to get the proper fuel air mixture for ignition. So another definition is a device that determines the mass per unit time to determine the flow rate or quantity of a liquid or gas moving through a pipe, like kilograms per second. So there are also other types of mass flow meters such as Coriolis mass flow meters. So Coriolis mass flow meters measure mass by inertia. So a liquid or gas flows through a tube that is made to vibrate by a small actuator. So this artificially introduces Coriolis acceleration into the flowing stream, producing a measurable torsional force in the tube, so resulting in a phase shift. So when no liquid is flowing, the motion of the tubes is symmetrical as shown in animation. But if there's a fluid flowing, the two vibrations are out of sync just like in animation. So Coriolis mass flow meters are used in a variety of applications across a wide range of industries as well as scientific applications, measuring both corrosive and clean gases and liquids. They offer high accuracy in mass flow measurement, so density measurement, temperature measurement, and viscosity. So another type is thermal mass flow meters. Also measures the mass flow rate of gases and liquids directly. So these meters operate either by introducing a known amount of heat into the flowing stream and measuring an associated temperature change, or by maintaining a probe at a constant temperature and measuring the energy required to do so. So kaning molecules naga-flow once na moagi ni siya aning red tube nga heated, kay makarry ni siya ang heat. So the more naapaspas ang flow, the more molecules ang makarry og heat. So the components of a basic thermal mass flow meter include two temperature sensors, electric heater between them. So the advantages of mass flow sensors are high precision liquid flow measurement used to measure a wide range of fluids including highly viscous liquids. So the advantages of mass flow sensors is low density liquids cannot be measured, vibration, interference is extremely sensitive. So the ultrasonic flow meters is the ultra high frequency sound waves are used to measure the velocity of particles in a processed liquid or the time it takes for sound waves to penetrate the liquid. So ultrasonic flow meters work on the principle of using sound waves to break down the velocity of a liquid in a pipe. So kaning sensor mo ay transmit and receive og ultrasonic signals. So the advantages of ultrasonic flow meters are temperature, density, and concentration have no effect on transit time meters, materials that are suitable for chemically aggressive liquids. So the disadvantage of ultrasonic flow meters are because the sound beam must traverse a representative cross-section, it is flow profile dependent, long inlet and outlet sections are necessary, clean liquids are required for transmit time meters. So, accuracy of measurement. In many cases, you will have several options to choose from, all of which are suitable for your situation. Some may, however, provide a higher level of accuracy than others. So, consider the level of accuracy that various flow meters can provide. So, a positive displacement flow meter is one of the most accurate types of flow meters available, but it may not always be the best choice depending on the application. Next is cost effectiveness. You might come across a flow meter that provides highly accurate result but is out of your price range. Try to strike a balance between finding the best option and staying within your budget. You might come across an extremely low cost option that appears to be usable. So however, if it is too inaccurate or stops working soon after installation, it will cost you more in the long run because you will have to replace it. Look for a product that provides quality and durability, even if it means spending more money upfront.